Welcome to the plenary session on sector integration. So in the next hour, our speaker will share their side of the story on how this, let's say, buzzword means for them, and how it make our energy system smarter, more efficient, and obviously more sustainable. My name is Alessandro Provaggi. I'm head of DSC Plus, which is the innovation platform at European Power, the European Association for District Energy. Before I forget, I have to tell you that this session is being recorded. And also what you see here, very important, if you want to make questions, you have to use Slido, so the way I'm doing it. And you see the code over here. You can also, by the way, use the QR code, and then you have to go to the session plenary number 4. So back to the content. You may know that the Green Deal is the big priority of the European Commission. Maybe you know and not know that energy integration is a key pillar of such a Green Deal. 2-3 months ago, the Commission released a strategy on energy system integration. This strategy basically says that we need to break the silos between the separate networks. We don't like anymore, let me put it this way, that the energy systems is going on parallel networks that are not integrated. This is too rigid, this is too wasteful. And so we are going toward a pathway where there is more a circular energy system with energy efficiency at its core. Now, we are going to discuss all this with our speakers, and you see their names in this slide. So Christopher Gucci from Cybergrid will bring the point of the aggregators. Federico Boni Castagnetti will bring the point of Iran, the utility sector. Dieter Most will bring the point of a key player, Siemens. And then Luca Lo Schiavo will bring the point of the Italian regulatory agency for energy. Let me say also that Christoph will shortly touch upon the project Magnitude and Federico over Planet. These are two projects that deal quite extensively with energy integration. So with that, I'm pleased to pass the floor to Christoph. So I'll ask you to take the floor and to take control of the screen. So Christoph is a PhD from Graz University of Technology. He's been with Cybergrid since 2012 and is an expert working on industrial demand response and electricity market modeling. And as I said, he will also introduce the main results of Magnitude. So Christoph, the floor is yours.
Good morning to everyone. Thank you for the introduction. I will directly jump into presenting the Magnitude project and the learnings that we achieved in this project. So,
Christoph, can you just change to presenter view, please?
Is it better now?
Yeah, perfect.
Yes.
Thanks.
Okay. Yeah. So the Magnitude project is dealing with multi-energy systems for sector integration. The aim is to investigate the synergies between electricity, gas, and heat networks. And the Magnitude project is focusing on its investigations on 7 real-life case studies, which is the steel industry and the gas network in the UK, pulp and paper industry in Austria, district heating systems, in Italy and Denmark, district heating and district cooling systems in France and Sweden, another district heating supply in CHP in Italy, and wastewater treatment and sewage gas exploitation in Spain. The analysis of the project include technical simulations of these sites, facilities, aggregation and market participation, and investigation of the issues there, developing of business models and cost-benefit analysis for these sites, and these sites acting as multi-energy systems, providing flexibility to the energy network mainly, and also listing or finding and listing the drivers and barriers, and developing policy strategies and recommendations. And finally, also there is a work package dealing with improved market design. So let's go straight. What's the principle that we're investigating? So our working hypothesis is that the electricity network is very vulnerable and needs control in milliseconds and seconds to maintain a balance between generation and consumption. And it's not always easy to maintain this balance because of renewable generation mainly, which is getting a higher share in our networks. On the other hand, the consumption pattern is still the same as it was, or similar as it was 20 years ago. So now we have more fluctuating generation and feed-in, but still at a rather static consumption, and we need to keep the balance between these. And the idea is that we can use flexibility from gas and heat networks, which are far more resilient than the electricity network, so that these gas and heat networks can definitely help to balance the electricity network. So, and in our case, we are focusing on multi-energy systems, not only as in the case of generator, but also, and this is a main focus, as a consumer of electricity. So what does balancing mean in that case? So that's what you can see on the lower line of this slide. So in a normal case, we have a certain consumption of electricity and natural gas, for instance, from the public networks. And in case that a multi-energy system would provide a positive balancing, it can reduce the electricity consumption by means of increasing natural gas consumption. So there is a shift between energy consumption between electricity and gas network. So this can help the electricity network to stay balanced. On the other hand, if there is a need for downward or negative balancing, for instance, if there is too much renewable generation in the system, then the multi-energy system can increase the consumption of electricity on the cost of reducing consumption of natural gas. So basically, this is shifting the imbalances from the electricity network to the gas network. But as we learned in many technical studies, the gas network is much more capable of dealing with these imbalances than the electricity network. So that's the main principle, and we are investigating the possibilities of multi-energy systems to support this principle. So let me tell you about the magnitude project that we assume that all this integration of multi-energy systems and improved flexibility provision for multi-energy systems should be market-based. So this is in line with the European policies, and we are investigating, or we are assuming that the existing market services and mechanisms are appropriate, and we are investigating how far we can get with this assumption, and if we find out some challenges based on the existing services. So the services that we are investigating is the day-ahead and intraday energy market for electricity, then MFR, AFR, and FCR, which are typical ancillary services in continental Europe. But also, finally, we also investigate flexibility provision to grid operators and system operators like redispatch services, also in the distribution network, and capacity mechanism to ensure the annual peak load coverage. So, and another aim of magnitude is to simulate the workflows as they appear in the practical case. So we want to be close to reality. And this also means that we need to deal with uncertainty, which is highly influencing the decisions that have to be made by the aggregators and by the operators of the multi-energy systems by themselves. So let me briefly explain how this runs. And the first step, aggregation platform creates price forecasts. These price forecasts are used in the technical models of the multi-energy systems to create flexibility forecasts. The aggregation platform will collect the flexibility forecasts from different multi-energy systems and create flexibility bids. These flexibility bids are tested on a simulated market, and the market returns with the bid acceptance. And finally, when the bid was accepted, we're simulating real-time operation, and the aggregation platform calculates the dispatch of the technical models. And at the end of the day, at the final result of the simulations, we can receive the operational data and the cost of operation of the multi-energy systems to provide these services. And from the aggregation platform, we can learn about the market revenues, and this information is used to develop and test different business models. So that's the simulation. Now let me show some learnings that we received or that we already achieved in the last years. So Magnitude is already in its final phase in the last 6 months. So we already have 3 years of investigations and a lot of learnings. And yeah, let's now jump to the learnings. One thing we need to be aware when we are talking about the market-based approach can solve everything is that the energy customer does not only pay for energy from a market perspective, there are also quite some overheads on top of the market price. Well, we all know that. So this is, of course, the grid tariffs and energy taxes. And what's becoming more and more important is renewable supporting schemes. So in most European countries, the consumer of electricity has to additionally pay some contribution rates, so that and this money is taken to fund and support additional renewable generation. So what we can see on the bar chart on the right hand side. So for electricity and natural gas, the green part means the share of the energy price that the industrial consumer in the medium voltage network has to pay for electricity or for gas. And we see first learning was that the overheads for electricity and for natural gas have about the same percentage of 40 to 60 or 80%, depending on the countries. But we also learned that even if electricity is getting very cheap, the overheads of the electricity are still dominant, and they will still be more expensive than the total cost of natural gas. So a simple shift of electricity to natural gas consumption is not that easy because of these overheads. And so this drives us to the conclusion that if we want to get more flexibility from multi-energy systems, we also need to talk about these overheads and network tariffs and grids. And in some Austrian case that we depicted and showed in very much detail, we found out that even the renewable contributions that these multi-energy systems have to pay are preventing them from supporting renewables by providing flexibility. So there is some funding mechanisms which are directly can be considered as a barrier for multi-energy systems. So we identified far more challenges, which maybe we can discuss in the afterwards. Mainly, we see a multi-energy system and market services. The product definitions may be too strict. So ancillary service products in the past have been developed for generators. Now we want to bring multi-energy systems as energy consumers into the market. So we need to shape the products in a way that they can participate. This mainly means shorter product duration and short gate closure time. So that's I can say that the ongoing development in the ancillary service markets in Europe is supportive or will be supportive to the participation of multi-energy systems. But another issue that we found out is that there is no there's a very low rate of harmonization between different markets in Europe. So even between neighboring countries like Slovenia, Austria, and Italy, there might be completely different market schemes, and this is limiting the replicability of our ICT solutions. And finally, what we found out also with respect to ICT solutions and understanding of the systems, there is a huge amount of stakeholders in the process and the business process, and the business process is becoming more and more complex. And finally, the last conclusion that I want to point out here is that intraday markets will play a major role in the future, and there is a lot of work has already been done to make these intraday markets more liquid, but we still see this as a big issue for multi-energy systems. If they want to provide flexibility to the energy system, then we need a liquid and working intraday market, and that's not the case in all European countries. So I was told not to speak too long, so I want to.
Thank you very much, Christoph. That's perfect, and at the same time very clear. There is a question. Do you know about any let's say best practices? Maybe some member states or some cases that are doing let's say better or more advanced on level of energy integration. You mentioned maybe Austria, or maybe there are others too.
Yeah. Well, in all European countries, we can see some good practices and also some bad practices. As you mentioned, for instance, in Austria, we definitely have a very supportive scheme. The Austrian TSO is very innovative in this respect. And in general, I could say that smaller countries are more open to support the market participation of multi-energy systems because they have issues with market liquidity, and they want to support additional market participants to join their markets and provide ancillary services. So if we want to learn about best practices in general, we should study smaller countries like Austria, Slovenia, maybe Belgium and others. And the general, it's that the smaller countries are ahead of the larger countries in that respect. So let me say this in a diplomatic way.
Okay. Thank you for your point. So I'll pass to the next panelist, Federico Boni Castagnetti. Welcome to you as well. So Federico has been working in the field of power plant and district heating design. Is also dealing with a lot of innovation projects on smart grids, e-mobility, and etc. So Federico, I'll let you explain it better. The floor is yours.
Yeah. Okay. Can you hear me and can you see my presentation? First page?
I believe we can. Yes.
Okay. Perfect. So nice to meet you all. My name is Federico Boni. As you were saying, I work in Iran. Just one slide to show what is Iran. Iran is a multi-utility dealing with several aspects of services for cities and customers, let's say. We are based in the northwest part of Italy, but we are now expanding throughout Italy. We are for the idea of this project and these meetings, we are almost in all sector of the energy market, let's say, and the energy world, apart from the TSO, that is there's just one TSO in Italy, and it's a public company. And so this is the idea. To come to the Planet project, where so we are participating in Planet. Planet is a project that is again studying, as the project before, I think maybe in different point, the integration of renewable energy in electricity networks, but also the possibility to coordinate and integrate energy vectors to, let's say, overcome balancing problems or other issues related mainly to renewable integration in the electricity networks. My presentation today want to focus on what we are doing in our pilot in Iran in the Planet project, because I think we did and we are doing some good works testing, let's say, and testing the basis to then do what also the previous presenter was saying, so participate in the energy markets and trying to sell flexibility. In that case, what we did is we found out a building where it's a public building where we are facility manager for the municipality in Turin. This is the photo of the buildings. It's quite a large building with several different uses. And in that buildings where we were managing the heating and cooling system, we integrate a heat pump, quite a big heat pump of almost 60 kilowatt of electric power input, and more than 180 in thermal power output, let's say, both for cool and heat. We substitute one of the old chillers, and what we did is to try and test what a heat pump is feasible, can achieve in terms of flexibility during normal use. So again, here we need to provide comfort to the people inside. Maybe this can help. It's in Italian, but I will explain to the one who cannot understand. This is before and after our project. We had 2 chillers and 2 boilers that were providing all the comfort to the buildings. Right now, we take out all the chiller and we installed these heat pumps that can give us the possibility to switch, in some cases, between gas and electricity, to have the possibility to sell flexibility in some networks, or to be flexible in operation again. So this is the idea, the basis. This is what we wanted to test. It's for us the first time we have this kind of pilot, and we use a heat pump in that sense, and we are facing, or we are discovering some, let's say, good point, but also some drawbacks or some blocking point in some cases, to then understand really what can be feasible once we are out of a European project, once we are out of a study project, and we get to a market idea. That idea of having some kind of electricity usages that can be in some way shifted and substitute sometimes to provide flexibility, it's an important thing for Iran, and so we are testing it in several other projects. I just want to say, without going into deep in all of the project, that let's say in Planet we have a heat pump that can be shifted and you know, turn on and turned off. For example, in a project like V2G evolution to grid, the idea is to have a car that will provide, let's say, the same, at least in terms of idea, the same services to the network. Again, moving the consumption or the injection, in that case, of energy in the electricity grid. We are doing it also we are dealing with power to gas integration in a project that ended in reality. And so this is the idea at the basis, and this is what we are doing in Planet. Planet will end the beginning of 2021, and let's say we are waiting for the winter to come to have, let's say, more reliable test during the heating seasons, where we are going to test this kind of flexibility. Let's say we are not in the market yet. We are going to do offline tests, let's say, to see if an heat pump used in that way, it's really flexible or not. That's, I think, it for me.
Thank you, Federico. There is a question that was actually addressed before to Christopher. Maybe I'll invite you to answer if you wish to do so. It says, a natural gas is a fossil fuel, and hence it should be eliminated as soon as possible. Also, the difference in cost totally depends on the CO2 cost. What do you think? If I understand well, the question is about the CO2 pricing, so putting a price on CO2. Maybe I thought that was interesting for you because it may play out for the heat pumps, for example, against a gas boiler and so on. Do you want to spend a few words on that?
Let's say, okay, we agree that gas is more pollutant than, let's say, the burning gas in such a small, maybe boiler. It is more pollutant than using other kind of heating and cooling systems. But we need also to take into account the real, for example, in that particular project, I don't want to go too much in that particular project, we need to know that some part of this building needs high temperature heating that cannot be provided in an efficient way, or even cannot be provided at all by an heat pump. So in that kind of things, we need to understand really that we need to move to more less pollutant, let's say, technologies, but we need also to wait for the building to be ready. And so this is more complicated stuff. So in Iran, we are looking for these kinds of transition. We are investing on it, but I don't think that is something that, okay, from today to tomorrow, we switch everything to electricity or other.
Okay, thank you for that. So I'll pass the floor to our next speaker, Dieter Most, who is a senior engineer in energy electronics and at Siemens. His work is focusing on modeling, feasibility studies, innovative technologies, and business models for the future energy system. So Dieter, please tell us about the future. The floor is yours.
Okay, hello. You can see my screen already? No.
Yeah. Yes. Yeah. We can.
Okay. Okay. I'm at Siemens for 15 years now, and the last 5 years I did a lot of modeling for multimodal energy systems. This means not only electricity, but also including transportation, mobility, heating, cooling, fueling gas, and these things. All but an energy system really is about, all relevant sectors. And I did several studies on Germany, on France, and some other on the world, like Brazil and these things. And what we also did in this funding project plan for us here, we joined this project and did a modeling of the pan-European energy system under aspects of sector coupling and multimodal energy sources. And I could bring you today some aspects of this sector coupling, how important it is, and what can be done with it, with a focus on district heating and the coupling of gas and electric heat via power to gas. This is more or less the essence of all these multimodal studies, the identified challenge and levers we have to address on the pathway. We are modeling a pathway from now to then, and with regional resolution, and trying to find an macroeconomic optimum, what we can do, and how and when we have to invest in certain technologies. And what we find out about all these technologies is, for Europe, we can do a 90% CO2 emission reduction. Is achievable with today's available mature technologies if we realize the full potential of sector coupling, and we head for a pan-European cooperation of the energy system, not national systems only, but cooperation. This is a macroeconomic optimum. Not everybody is following this way, and we have national energy plans when we have individual decisions. So what if we not follow an optimal pathway? If we have a case of delayed measures, or we have excluded some low decarbonization measures like sector coupling, or we don't go for thermal storage, then we need some new technologies like carbon negative technologies. So we have to implement hydrogen in really huge amounts. And this will be necessary to achieve our targets for the CO2 emissions. And this comes at an increased cost. And today, I'm focusing on these two topics: decentral heating, decarbonization, and alternative fuels. And if you go for heating, a lot of people are talking about green gas for boilers, power to heat. But what I'm heading for is the district heating, because it's really showing what sector coupling can do. And we're starting with the challenge of heating. Yeah, we still have about 47% of final energy demand is used for heating in the European Union. So it's really a big topic we have to decarbonize. And in the next decades, we have two big challenges. One is we have a phase out of coal power plants and fossil power plants in some countries. And this means in the cases where we have a heat obligation for district heating, we have to replace it because the heating demand is still there. And we also have a replacement of oil boilers for space heating. In many European countries, they will be forbidden in future. So we have to find a suitable replacement for these oil boilers in the decentral space heating. And as I told you, district heating will stand its ground. It's had some advantages. It's future-proof, and it can implement heat recovery from industry and some new opportunities. For example, given data centers or power to gas units or whatever you have for smaller units there. And it can provide cheap storage of surplus energy, and it can provide flexibility to the energy system. It should really realize this, because it's important to keep costs down. And it can be an alternative to gas boiler and a gas grid extension. Yeah, if you go there. And what we can see in all our studies, that district heating will grow its share, and we have a 12 to 15% in share in space heating and low temperature heat supply for district heating, yeah? Not power to heat only. So, but coming for the challenges, yeah, okay, we have to find new heat supply. If we have a coal phase out for the power plant, so the phase out of the coal power plants in next to 10 to 15 years. And this means that the large district heating equipments have been supplied with some new heat, cold generating heat, and of new power plants, maybe gas power plants, and they're coming more important, yeah? And if you go for an aggregated fuel, yeah, you can calculate this and see that, okay, we come up to 90 terawatt hours of heat demand for Germany on the heating grids, and we find about 26 gigawatt of thermal power from cold generating heat and power plants. This will be fine, and then we can meet this from an aggregated fuel. This sounds easy. Okay, we can match supply and demand. Okay. On the local perspective, it's much more complicated. Why? Because we have a limited supply radius for the heat. We have to really disaggregate to the plant units where we can locate them, and we have to find the district heating grids, and we have to match everything in single regions together, and then we can check if this is really working. And this means that not only aggregated perspective, but also local perspective is very important to check if this is feasible here. The other topic is the challenge that we have to find a replacement for the oil boilers here. Yeah, so basically we think about two options. We have a decentral gas boiler to install. This is a big disadvantage. This means in most cases that we have a gas grid extension, which is necessary to really supply all these new gas boilers in the decentral rural areas, for example. Yeah, then we have a risk of stranded asset. If we have a phase out of fossil gas in the future, and at the end, 2040, 2052, then this means that we have built a gas grid and nobody's using it anymore. Yeah, or we can go for individual decentral heat pumps. Yeah, it's a fast solution. It's nice. We can put it there. Often it means also an extension of the electric grid now here, but it provides some storage option, but it's only limited amount of flexibility to the local electricity grid. Why? Because you have to aggregate lots of individual consumers here, and you have to motivate them to join in these storage and flexibility options, and this is much more complicated. So there's only a limited option there. And most of all, we have the risk that you end up with a lot of cheap but inefficient heat pumps. Why? Because the individual consumer buys a heat pump which is of low capex, and he does not really need, go for the efficient ones. Yeah. So this is a risk here. Another option, maybe local heating grids, small local heating grids. I'm talking about several streets or so. Yeah. We can use a central heat pump there to provide a local heating grid, hot water, and bring the heat to the households. And then the central heat pump is owned by a local municipality, and this usually makes it much more easier to provide storage options and provide flexibility because you have one owner who can do this. Yeah, and we can also implement cheap hot water storage, pit storage, like the Danish people do, for example. Yeah, and this gives us a lot of flexibility. We can store energy for days here. Yeah, and a local heating grid also holds opportunity to implement heat recovery from local waste heat, yeah, from local industry, data centers, whatever. So other heat sources can be integrated in this parallel. And this is something which might be an alternative to the other two options here. Yeah, you really have to should think about this. Yeah. Okay, if we say stick to a gas grid, yeah, and they would need this for the heating, or we will really rely our energy system still on gas in the end of 2040, 2050, we have to think about replacing the natural gas by synthetic gas. And this brings us quite soon to the question, how much hydrogen or synthetic gas can we inject in the our gas transport grill? Do we have bottlenecks in the transportation systems? Yeah, and usually my impression is that power to gas is treated often as a cure for electric grid issues. Yeah, from the electric side, people have something like a bottleneck there, then they say put some power to gas units and you can realize the surplus energy and everything is happy. This is not the case. Yeah? What we have here is, or what we do in the Plant for Rest project is for addressing this question, how much hydrogen can we inject in the pipelines? We have electric grid model. We know about our investment plans, where the location and the operation of the gas power plants are. Yeah? We can put this here inside. Yeah? We know from our placement where the power to gas units would be best. Yeah, we're considering both sides, electric grid and the power to the gas grid here, where to place it best. Yeah, and we get a schedule for the power to gas units. And we have from the gas grid model location operation of the gas demand, residential, industrial, and where the supply is coming from. And sometimes the supply is passing through Germany to supply other countries here. And then we can check where we find bottlenecks and invisibilities. Invisibility, for example, that we have a too high hydrogen concentration, so it's, the gas system can tolerate this, yeah. And we can make a list of change requests and we can put it to the other models for the electric grid model or the placement of the power to gas units and refine it a little bit. And but also coming here, the old picture was for Germany. Now this we have to do in the Plant for Rest for Europe or for parts of Europe, and it's much more complicated. As these two pictures here show, the electric grid on the left side, the gas grid on the right side, to do also placements here. And especially for the gas grid, we have still some issues with getting all the data we need and the right data. So this is really an ambitious topic here. So this is, I'm at the end here. My final message is sector coupling is a really cornerstone of decarbonization, especially if we think about heating and decarbonization of heating. It has to be integrated in the modeling of integrated energy systems, really from the beginning, not afterwards and some breakouts and so. You can find more about our project Plant for Rest here on this webpage here. These are the consortium partners. If you have very interesting case studies. Most of the work I'm working on and these results are coming from this case study, integrated multimodal pan-European energy concept for achieving COP21 targets with sector coupling, with all the electricity, heating and cooling, mobility and fuel of gas. And here you see our model cascade. We are using multimodal investment model for the EU pathway from now to 2050, disaggregation EU commitment and the transmission grid model for the electric grid model and the gas grid operation model. So I'm finished now.
Okay, thank you, Dieter, so much. Very interesting presentation. I could also say that from my district heating hat, we were also, let's say, pleased to see, for example, in the energy integration strategy of the Commission that district heating will have a prominent role because it can capture waste heat and it can also balance the electric grid. Now there is a question for you, or more in general. Sector coupling is important, but how fast the current structure of our energy market can stimulate sector coupling? Do we need a special market structure? Any view on that? Anything may help on market point of view.
Okay, in our models, we don't go so much for the market. Our lever is the CO2 emission price. Yeah, we put on the all the technologies and the commodities. We're using an ETS analogy and saying, okay, oil is more carbon emissions, gets a higher price, and we're seeking not only the macroeconomic optimum but also for the least CO2 emissions. Yeah, and this shows us that it's coming up because it gets macroeconomic feasible. Yeah, from discussions with some utilities and municipalities, we see that there is some problems from the individual decisions. Yeah, how can I bring people to connect to a local district heating grid? Yeah, that's very important thing, and not implementing a very inefficient heat pump on my individual house. Yeah. So this motivation thing is still not solved, and I don't have an answer to this, but it's a very important point to get the end consumers joining in this thing here.
Okay. Okay. Thank you. Thank you, Dieter. I'll give the floor to the next speaker, Luca Lo Schiavo, who is Deputy Director for Infrastructure Regulation at ARERA, the Italian regulatory authority. Is an expert also on, let's say, service and innovation in the power system. Luca, please, the floor is yours.
Thank you. Luca Lo Schiavo speaking. Thank you for the invitation. Can I check if you see my screen?
Yeah, we do.
Thank you. I work in the Italian Regulatory Authority in the Department of Energy Infrastructure Regulation. And I want to bring to this conference a rather recent perspective that European regulators of energy, meaning mainly electricity and gas, are developing in their reasoning. And it's about what we call whole system approach. Whole system approach is a rather general concept, meaning that we all, I mean, not only regulators, but also market and grid operators have to think of our initiative, of our actions, of investments in the perspective of the net benefit for the entire system, entire energy system. And this can be a big change, especially for us, for regulators, that have so far mainly been structured in vertical ways, covering a few sectors. Why we consider this approach beneficial? Because we fear that looking at each singular sector separately, or even at each singular activity within a sector, I will explain in a few minutes, this can be suboptimal. So we start in this example from the system chain, for instance, of electricity, and all of you know that nowadays decentralization of the system is the real transformation in every country, especially in Europe, but not only. And of course, normally regulators look at, for instance, electricity distribution in a focused way, without without full system approach. So a first step that we call layer 1 is to looking integrately network operators as a whole, so distribution and transmission. This is a first layer that has still relatively little to do with energy integration, but is very important because the boundary between transmission and distribution is not the same all over Europe, and the true transformation is nowadays in distribution. So the second layer is really very important, and is to look at the whole chain of each system, the whole chain. So looking not only at grid operators, but in an integrated way, also to activities that are in competition, like generation or like supply. This has much to do, for instance, because we in Europe have a strict rule of unbundling, of course, so all grid operators cannot do activity competition, but they must think of the impact of their investments in the competitive activities. This is also a reality for transmission, thanks to European regulation that consider the benefits of new investment in transition in the light of effects in the market, either wholesale and both wholesale and retail. The third layer is the cross-system approach, looking at more sectors. So looking at regulatory focus, let's say, on whole energy across several sectors. Here, a first barrier can come from institutional building, because in many countries, different sectors are under different jurisdiction of regulation. And we, as a regulator, must evolve, let's say, towards a multi-sectoral approach. And I would say that Italy is one of the countries of the European member states that is going to do such a move, such a change in regulation, because recently, in the last, say, 10 years, the Regulatory Authority for Electricity and Gas was mandated by law to enlarge its jurisdiction, first to water and recently to waste management, and also to district heating. That is not so developed in Italy as in other Nordic countries or Central European countries, but still exists, especially in the northern area of Italy. So we now regulate 5 sectors, and this is a challenge for us to look with a higher coordination among the different sectors.
Luca, may I ask you, what is the main challenge that you see from the regulatory point of view to enable the energy integration? What is, the biggest problem you have?
May I answer through, just to say that this chart has been drawn by a paper that I want to signal to everybody in this conference. This is the reference, and of course, slides can be published. What are the challenges? There are so many. It depends, of course, on where we apply such an approach. First of all, things must be experimented. So there is an innovation point. There is not a single recipe. There is not a one-size-fits-all solution. For instance, in Italy, we are now in a consultation phase to launch pilot projects in an innovative framework for power to gas, or power to heat, or other integration initiatives. there is a consultation phase, or even for hydrogen, of course. And here we think to put a pot of money in order to test in field how these new plants can really work, how can they, for instance, location is a first challenge. We are going towards a world where renewables are already extremely developed, but they have to be more and more developed. This can bring to hours and maybe days when the price of electricity in the wholesale market is very low, or even zero, or even negative. And in this case, a good occasion is for power to gas. So the location in order to collect energy that otherwise would be over-generated is very important. Of course, also there are a lot of technical issues that I've seen in the previous presentations. And then another point that also is being quoted in by the other speakers is the aggregation of distributed resources. I fully agree with Mr. Gucci's presentation. This is a big point. The regulation is not the same in countries. Austria is going on, Italy is going on. We launched what we call a pilot regulation for aggregation of distributed resources. And here there is, of course, an integration with the industrial process in the demand side. So again, we look at the whole chain in such a way. There are also the very important decision investments. Here, an important challenge is that scenarios for development plans are joint, at least among electricity and gas. And this was not the case until a few years ago. So developing joint scenarios is a challenge both at European level between ENTSO-E and ENTSO-G, but also at national level. We mandated our TSO, gas and electricity, to make such an effort, and it has been recently developed a joint scenario document in Italy, as it is in Europe nowadays.
Okay, thank you, Luca. Sorry, I think we have a really few minutes left for the dialogue, so I need to go on. If sorry about that. So if you have more questions, you can type into slido.com. There is actually a point on not having women in the panel, which is a point that I think is pretty fair, and I promise I'll pass it on. Apologies for that. So now maybe a question for you all. How do you see the role of the consumer? We didn't discuss it maybe about that, but I saw it here and there in your presentations, vehicle to grid, prosumers, aggregators. Who wants to step in? Like, because energy integration is also about integrating people and consumers.
Yes, may I start, Lucas?
Okay.
Yes, retail and consumers is really a first step of a level of change. It's very important to say that at least in many countries, for instance in Italy, retail is inherently energy integrated. For instance, there are suppliers that offer both electricity and gas offers. There is an important effort that suppliers can do in order to change their view, not only being price driven, but being service driven. They can look at energy saving, they can look at different ways of providing energy for the final usages. This is extremely relevant, and I think that only an evolution in the mindset of suppliers can help in such a way. But consider that already there are dual offers. For instance, an important topic, and I stop, is mobility. There can be a solution for energy integrated utilities to catch also the mobility needs of the customer. This can be done in a competitive way according to the competition rule policy of Europe. We already have a few suppliers that offer an integrated package for gas, electricity, and mobility with fuels, traditional ones, or even electricity for the car. A very important topic is that there are no distortion in final tariff.
Okay,
That's
thank you. Christoph, maybe you have a few points as well on the role of the consumer?
Yeah, indeed. So thank you for this question. So I agree with what Luca has said before. Apart from the residential customer, there's also the industrial customer. In that case, of course, we see that the decision is usually price-driven, and the comfort is not the main driver here. And what we see is that it's becoming more and more difficult to compare prices between different energy carriers, because the price structure is becoming more and more difficult, and there are more and more taxes and subsidies on top of it. And so this is something which even for professionals in the industry is becoming more and more difficult, and simplification in these schemes might facilitate the engagement of customers. On the technology side, we don't see a major barrier, and we have from Cybergrid, we have good experience for about a decade with providing flexibility from industrial consumers to grid operators. So the technology is there. It's not about the price signal that the industrial customer must receive so that they are really willing to participate.
Okay, thank you. There are also a couple of questions, maybe for Dieter and Federico. One question is, on heating, are the best solutions similar for new districts where district heating is easy to implement, and for existing districts? David, Dieter, is a question you'd like to take?
Okay, I can talk about this. What we see currently is that a lot of, for the cities, there are existing infrastructure is already given. So it's most times it's retrofitting or extending an district heating grid. Yeah? And if you want to implement in big cities and district heating grid, you have a lot of challenges. But what we also see is these small grids may be an option for the rural areas, where we have the problem of the phase out of the coal heating, the oil heating. And we see a lot of mayors coming up to the municipalities and saying, please extend the gas grid in our villages, to our streets and so on, so that we can provide our citizens with gas boilers. And then we have the option between a gas grid extension or a district heating grid extension. And that's the same thing. You have to dig into the earth and do some pipes somewhere. Yeah? So I think there's a lot of potentials, not in the cities, but in the rural areas or in the decentralized areas, villages, streets levels, these areas.
Okay, thank you. There is also another question on the biggest energy efficiency potential. So the biggest energy efficiency and cost efficiency potential through system integration. So there is, maybe who wants to reply to that? I don't know, Federico, Dieter, anybody?
Yeah, the biggest potential for from the CO2 emissions is heating.
Okay.
Yeah? That's nearly half of the final energy we're consuming for heating. So this is where you have really to decarbonize it. Yeah, it's on the way, because power to heat is a big good solution there, and it comes automatically with the decarbonization of electricity. But it's not electrification. It's not the sole solution for decarbonization. And the next thing is transport, yeah, because transport has nothing done in the last 20 years. So it's still at the same level. So it's really time to get this thing done. And what we have to be careful about is all these data and communication and data streaming and so on, because it's really popping up and it's necessary for the decentralization. But I saw some studies. Today, it's about 1% of the global electricity demand, and it might pop up to 8 to 20% of the global electricity demand. And then it's the same dimension as mobility is today. So we have to take care that we have efficient ICT technologies on board. These are my topics.
Okay, thank you. There are any reaction to that? Otherwise, I think we almost have to conclude. So may I ask you to your final messages, if I can put it this way. Christoph, do you have any, let's say, any remaining messages for the audience?
So I think most important things have been said. Maybe picking up one question which we did not discuss from Slido. It's basically mentioning that the gas grid is also not CO2 neutral. That's true, but we can still say that it will not disappear in the next 20 years. And we should see the multi-energy system as a bridging technology until we have maybe in 50 years we can reach a fully decarbonized industry. But it will take some decades, and during these decades we also need to have a efficient, let's say, energy supply and consumption system, and the multi-energy system and flexibility and sector integration will play a major role in this transition phase. Okay, thank you. Federico, any remaining comments?
Maybe I just want to comment on the idea of the customers. Of course, customers are fundamental, and I want just to put something for everybody, and then there should be a separated seminar only on that. But we are really studying, for example, what are the potential of energy communities. That is something that is spreading, that is being tested, and we really think as a multi-utility that there could be potential for all involved stakeholders, let's say, on that.
Thank you, Federico. Luca, any wrapping up comment?
Just a very short comment is about mobility. Leaders say that heating is a very important sector, but I want to remind that also a big change is coming in mobility. And also there, we must have an integrated approach. Otherwise, we risk to overinvest in distribution grids if we don't. And the way to avoid that risk is to look at smart charging. So provide the final consumers the electric car driver with signals that allow him to use the best way the system in order to charge his car. Possibly the change of cars will be a very important change in the next decade.
Yeah, very important point. Very important point. The one on energy communities. Dieter, you had the last words.
Okay. From what my models tell me that cooperation is very essential. The pan-European cooperation to have a security, supply, flexibility, but also the cooperation between the sectors. And unfortunately, today the stakeholders in the sector think their sectors as silos only. Yeah, so we have to overcome this and cooperate. And digitalization will really help to go there for smart cooperation. That's very essential, because if we don't go there, it will be much more expensive to reach our seals for the decarbonization of Europe.
Okay, thank you, Dieter, and also let me also thank all of you for participating today. Please also stay tuned with both the magnitude and the Planet projects. And I wish you a very pleasant rest of the conference. Thank you again to all of you and to the organizers. Have a good day.
Thank you.
Thank you. Bye, everybody.
Bye.